Okay, last one of chapter 4. Question 66A. Balance the following redox reaction occurring in basic media. Yeah, you guys better believe there's going to be one of these things on there. Okay, so we start with manganese tetroxide minus. All right, and again, you know me with the pens. I'm not writing any of the states, but I would definitely do it if I had better control. All right, Br minus gives us manganese dioxide and bromine trioxide minus. All right, so there's our reaction. Let's assign some oxidation states just to see what's going on here. All right, so oxygen pretty well always takes an oxidation state of -2. So that's going in there first. All right, see what we get. If we have problems, we'll deal with them after. Okay, so there's 4 of those, which means -8. But this compound has a charge of -1, which means that this is only +7. Only +7. Okay, and then bromine here. These are like the oxidation states of charged ions, or just whatever the charges are. So this is -1. Okay, and then in the products, manganese is now only with 2 oxygen atoms instead of 4, and this is a neutral molecule, so that means that this has gone from +7 to +4. So manganese has been reduced. All right, and how about the bromine? Bromine is now in an oxide. Right, 3 oxygens with a minus charge means that this has gone from -1 to +5. So the bromine has been oxidized. Okay, so the strategy for these questions is to write 2 half reactions, write your reduction, write your oxidation, no matter which in order, and then balance them as they come. And then add them together, eliminate what you got to do, and then, yeah. Okay, so let's do the manganese first. We'll deal with the reduction reaction. So manganese tetroxide, right, to manganese dioxide. Okay, so manganese is already balanced, right? So we don't have to do anything for that. We have to balance the oxygens. There's 4 here and there's 2 here. So we balance the oxygens with water. Now we have hydrogen over here that we don't have over here, so we balance that with protons. So 4 hydrogen protons over here. And then we balance the charges with electrons. We've added a 4+ charge over here. And this is and this side is 0, right? So 4+, so +4 -1 means that we need to add 3 electrons. So that means that 1 in total is it's 4 protons plus 3 electrons plus manganese tetroxide minus gives manganese dioxide and 2 water molecules. All right, so this is our slightly more complete equation 1. All right, and I'm going to fit number 2 underneath it, but then we're going to have to wipe the board after. For sure. Okay, bromine. What happens here? So bromide ion is oxidized to trioxide with a -1 charge. Okay, so bromine, balanced. Right, don't have to do anything there. So next is oxygen. 3 over here, so we're going to add 3 water molecules over here. All right, so 3 water molecules. That means that we've got hydrogen over here that we don't have over here, so we need to add the hydrogen to make it up. That's 3 times 2 means 6 protons. That obviously upsets the charges. This is minus, so that means that we just need to add electrons enough to cancel this positive charge out that we've added. Okay, and that gives us a complete second reaction. It is 3 waters plus the bromide ion is oxidized to bromine trioxide, 6H plus, and 6 electrons left over. All right, so now these reactions need to be added together. And they need to be added together in such a way that the electrons cancel out. We're going to cancel the other things out by different means. So let's see that we have 3 electrons in equation 1 and we have 6 in equation 2, right? And an important sanity check at this point is to make sure you have electrons on opposite sides of the equations. These are there's lots involved in these. It's easy to get mixed up in a step. So it's good practice to kind of check these things as you go. But in this case, multiplying this reaction by 2 means we'll have 6 electrons on both sides. So what we need to do is we need to add 2 times reaction number 1 to reaction number 2. And that's going to cancel our electrons. Okay, let's make some room and make that happen. There we go. Top was almost unscathed. Okay. So 2 times reaction number 1. That is going to give us. Sorry, give me a second. I have it written down somewhere here. Okay, 6 electrons plus 8 protons plus 2 manganese tetroxides two manganese dioxide and 4 H2Os. Okay, that is equation 1 times 2. Now we're adding to that equation number 2 underneath it. So bromide plus 3 water molecules gives bromine trioxide minus plus the 6 protons and the 6 electrons. Okay, so we can cancel the electrons, and we're going to cancel as much of the common things as we can. 8 protons here, 6 protons here, so these are gone, and this is going to drop to 2. And the other thing that we can usually cancel is some water. Here we have 3, here we have 4, so this is going to be down to 1, and this is going to disappear entirely. So the sum of our reactions then is 2 protons plus 2 manganese tetroxide plus the bromide gives bromide trioxide plus 2 manganese dioxides and a molecule of H2O. And that, I believe, is correct. So right now, this is the best opportunity to make sure that nothing has gone disastrously wrong. So first, the non-oxygen, non-hydrogen species, bromine is good. 2 manganese. Next, we'll do hydrogen. We've got 2 hydrogen here. 2 hydrogen here. And then oxygen. We've got 2 times 4 is 8. And we have 3 plus 2 times 2 is 4, makes 7, plus 1 makes 8. So we are balanced. We are balanced. And the charges too, actually. 2 plus charge, 2 negative charge means that we've got a negative here and a negative here. So the charges are working out too. All right, so that is the sanity check done. That thing is balanced. So this, if we were in acidic media, we'd be done. Because we're in basic media, we have one more step to do, which is to add as many OH ions as there are H plus ions. So we're adding 2 OHs, and we have to add that to both sides. And after that, this is going to form 2 molecules of water. We're going to cancel as many molecules of water as we can. So this means that this is going to disappear altogether, and we're going to have 1 water molecule over here. All right, so this gives us H2O. All right, 2 canceled, and that gives us the H2O plus 2 manganese tetraoxides. Oh, and 1 bromide. Sorry, this is so pedantic. It's like pulling teeth writing with this thing. Bromine trioxide minus plus 2 manganese oxides plus 2 OH minus 2 hydroxide ions. Okay, and now we check everything again. All right, so bromine's not changed. Manganese is not changed. Hydrogens, we have 2. Hydrogens, we have 2. Oxygen, we have 1. 2 times 4 is 8, makes 9. We have 3. 2 times 4 makes 7. Plus 2 makes 9. Elements, check out. All right, next is charges. We have 2 negative charges plus another makes 3 negative. So this is 3 minus on this side. Right side, we have 1 minus here plus 2 minus makes 3 minus. So the charges and the elements both balance. So this is our final expression. That is the balanced redox reaction in basic media.